Hello, geometry class. This is Miss Ellis. We're trying something a little new today. I am teaching video via video. Ha! Well, since I'm not there, I figured this is a good way that you can still get the instruction from me. And if I go a little fast today, that's okay. We'll put the video on the website that you can watch it again later. All right, I think you're going to like the notes today. We are starting a new unit. However, we're still in the world of triangles, which is just what we got done with, so it's very familiar to you. Now we're going to start with section 4.1, triangles and angles. And the first thing to remember is, well, triangles do have a lot of parts. Triangles require a minimum of 3 non-collinear points, so 3 points that are not in a line together. And they also need to have 3 vertices. They need to have 3 sides, and they will have 3 angles. Triangles, tri means 3, so 3 of pretty much everything. Now when we classify, we have used the terms isosceles, equiangular a little bit in the last unit, but there are so many more ways. And when you classify a triangle, you do it in 2 ways. The first way is by sides. Now the first triangle here that has 3 congruent sides on it, well, if all 3 sides are congruent, we call this equilateral. The middle triangle, you have 2 sides that are congruent. Your base down here at the bottom definitely does not match. Just the top 2 are congruent. That would be our isosceles triangle. Now the third one, we have not talked about this one yet. We have 1, 2, and 3 different lengths on all 3 sides. None of them are congruent to each other. So if you have 3 sides that are all different lengths, we call that scalene. Okay, so pretty much any triangle is going to be one of those 3 cases when you're looking at the sides. But we also can classify by angles. If you look at the first triangle, we've got 53, 67, and 60. All 3 of those measurements are small. And when I say small, I mean they're less than 90 degrees, which we learned earlier in the year was an acute angle. If all the angles are acute, we call it an acute triangle. The second triangle, well, this one, all 3 angles are congruent. That is equiangular. Okay, kind of sounds exactly what it means. Equal angles, equiangular. The third triangle, you've got that 20 and 30, which those are acute angles, but it's the one in that big angle in the corner, 130 degrees, that is an obtuse angle. You just need one obtuse angle, and we call it an obtuse triangle. And the fourth case over here, he's familiar with that nice little right angle in the corner. Well, that is a right triangle. Now, when you are asked to classify a triangle, from this point on, you will always use one term from the sides and one term from the angles. So you always give it kind of 2 names, one from each category. Okay, it could be equilateral and obtuse, or scalene and acute. So you're always going to have one from each category. So keep that in mind when we get to the examples. Now, because we are starting off a new unit, we do have a ton of vocabulary. A lot of these terms, again, some of them are familiar, some of them might be a little bit newer. All right, so vocabulary, first one, adjacent sides. They are 2 sides that share a common vertex. Remember, adjacent means that they're kind of next to each other, side by side, next door. So they're going to connect to one another by a vertex or a point in a corner. Legs in a right triangle, it's the two sides that meet at the right angle. In an isosceles triangle, it's the two congruent sides. So depending on the type of triangle you have, it does have a slightly different meaning. Be really careful with legs. The hypotenuse is the side of a right triangle that is opposite the right angle. Get my pen to work here. Okay, so that's opposite the right angle. Let me fix my N. We also have a base. The base is the non-congruent side of an isosceles triangle. Again, it's very specific to just isosceles. Now, the next two are going to be used a little bit today. Interior angles, well, they're kind of like what they sound. They are angles that are contained inside the triangle. Interior, inside. The angle's inside. Exterior angles are, again, kind of what they sound like, but they are angles that are adjacent to the interior triangles. Now, these are a little tricky because you actually have to extend the sides of a triangle to see them. What I mean by that, if I draw a triangle, I'm going to go over to the right. If I draw a triangle, the ones that are inside, these are interior. Let's do eyes for interior. 3 in the middle, interior angles. If I extend a side, I'm going to go with the bottom. If I extend that side out to the right, the angle on the inside that's formed right out here on the outside, that is your exterior angle. So you extend a side, gives you that exterior angle. All right, and last in the vocabulary, we have corollary. Well, it's a statement that can be proven easily using a theorem. And we saw a little example of corollaries. They're kind of like an extension of a theorem. You have a theorem, you can apply it to even more shapes kind of in a creative manner. So corollary, we'll see one of those down here at the bottom. Well, we're getting very familiar with using lots of theorems. That's pretty much what we've been doing the whole year. So new corollaries and theorems. We have the triangle sum theorem, which we did hint at a little bit in the last unit. The sum, that means if you add up all of the interior angles of a triangle, is always going to be 180 degrees. If you add up all 3 corners, all 3 angles, they will always add and equal 180. The exterior angle theorem. This one is a little new today. It says the measure of an exterior angle of a triangle is equal to the sum of the 2 non-adjacent interior angles. Now, that's got a lot of big words in there. So down here on the bottom left, let's draw a picture so you understand this just a little bit better. If I have a triangle and I extend out that bottom, so I'm getting that exterior angle, my exterior angle, we'll call it X, and then we've got 2 non-adjacent interior angles. Let's call them A and B. So the 2 angles that do not touch or form a linear pair with X. X will be equal to the sum of A plus B. That's how the exterior angle theorem works. It allows you to set up a nice little addition problem, solve for missing parts. And last but not least, we have the corollary to the triangle sum theorem. Okay, so it's kind of like a extension of it. It says the acute angles, acute ones, of a right triangle are complementary. Okay. And if you think about that, a right triangle, let's draw a picture of that down here. We know all three corners add up to 180 degrees. Minus the 90 degrees, which makes it a right triangle, that means the remaining two corners, let's call them x and y, well, x plus y will equal 90 degrees. Okay, eliminate the 90-degree angle, you've got 90 left, x and y, that fits the definition of complementary. So there's a lot of different kind of new terms, new classifications, new angle relationships that we're going to be looking at today. Okay. So let's try out some examples so you know how to